I love it when flat earthers try and do science. But today we have a demonstrable realist trying to do it. So take it away, Leo.
It's a demonstrable fact that any so-called curvature is optical and not physical. And today I'm just going to show you a very simple way to break the globe Earth theory using mathematics and two observers. We're going to chuck in a church of love as well. But first we want to get some globe mathematics, essentially the curvature, over two distances, 20 miles and 40 miles.
Okay, two observers, one at 20 miles, one at 40 miles, both 0 feet from the ground.
When we look at 20 miles, we get 266 feet of curve, apparently. And then we look at 40 miles, we get 1,066 feet of curve. Okay, so we've got those two as our reference for reference globe Earth curvature.
If we can just stop for a second, I'd like to point out that the figures of 266 foot and 1066 foot aren't actually measures of curve, they are measures of hidden height, which is different, but carry on.
And this is where it gets silly. So we got our two observers, observer A and observer B. Both are on the shoreline here. Observer A is looking at observer B, who happens to be 20 miles away. Observer B is looking at the Church of Love, which is in the opposite direction of observer A, but also happens to be 20 miles away.
Well, sure. That would be the case if you hadn't set the observer height as being 0 feet above sea level. What is in actual fact happening is observer A is wondering why he's got sand in his eyes, and observer B is wondering the exact same thing. Both see nothing but sand.
According to the globe Earth mathematics, there's 266 feet of curve that both these observers will encounter, which is cited as physical, but as we know demonstrably, it's only optical. And we're going to see again through globe mathematics why that is. So let's just assume both of these have the optical effects which are cited as curvature, and in their eyes the globe Earth would seem observably true, even though it's not demonstrably.
I'm going to stop you once again. Not because you've said anything particularly interesting, just because this is all we need to show that you don't know what you're talking about. Here, look at this. This is from the calculator that you used at the bottom of the screen. This is a visualization of what appears on the calculator. H0 is normally where the observer is, the horizon is normally where the horizon is, and the target is obviously the target. We are going to have to make some small minor changes because of how you set up the calculator. So in this case, we're going to place the observer at the horizon and the horizon at the observer, because they're the exact same thing if you have 0 foot elevation for the viewer. From observer A to H1 will be the whole 40 miles, which places observer B here and the Church of Love here. Now, let's take those arrows away and instead we'll place blue markers to represent the hidden height. This one is observer B, and as you know, it represents a hidden height of 266 foot. And let's place the same marker at the Church of Love. Looking at it though, something is telling me that we're going to need a few more to show the hidden height for the church. So let's place them in and see just how many are needed. You look at that. There's 4 of them. Now, it's time for some maths, Leo. What is 266 times 4? That's right. It's 1064. Sure, it's 2 foot off for the 1066, but it's close enough, don't you think? Honestly, I think that's probably more than enough to show that you don't know what you are talking about. But just for the fun of it, let's take that image again, tilt it, and centre it on observer B so that we can draw in a horizon line for him to see what the church's hidden height would be for him. Oh look, it's one blue marker, which as you know represents 266 feet. Now here's the thing, Leo. I know that you think that from observer A to the Church of Love should be twice the hidden height of A to B, because it's twice the distance, but that would only be the case if the Earth's curve was linear. Which it isn't. Because it's a goddamn fucking curve.
And that's, like I've just shown you there, is a simple way to break the globe, using its own mathematics, two observers, in this instance a Church of Love. Where did the missing 800 feet of so-called curvature go for observer A's observation when observer B, looking at the Church of Love, didn't encounter it? Obviously, I'm talking hypothetical scenarios here.
No, Leo, you're talking fucking shite.